Hey y'all, hope you're doing good and you're staying safe and healthy. Today we are going to go over section 2E notes, which is entitled The Properties of Matter. This is our last section for matter. So then we will start in with atoms and balancing equations and naming chemical formulas and whatever. Okay, so one more time, what is matter? It is anything that has volume and mass. Remember, volume is the amount of space something takes up. Mass is the amount of matter in an object. It is, in Birchworld, how much stuff makes it up. Okay? This whole chapter is called Properties of Matter. If we are going to be looking at properties, we ought to probably define them first. A property is a characteristic, quality, or distinctive feature of something. In my world, it's just a characteristic. We are going to look at both physical properties and chemical properties. They are nothing more than characteristics of substances. Okay? So, a physical property first. A physical property, by definition, is a characteristic of a material that you can observe or measure without changing the makeup of the substance. Okay? You do not change what the substance is. There are two basic groupings, I guess, of physical properties. One is with appearance and one is with behavior. So let's look at those real quickly. Appearance is things like shape, size, color, odor, hardness, state of matter, and density. Okay, it's what it looks like. So shape might be if it's round or spherical or cylindrical or trapezoid or whatever. Size may be, let's just say our flag in our room. It's 3 foot by 5 foot. Okay. Color, you understand what that is. Something that is red or blue or whatever. Though remember that with relative terms like that, even though it's not exactly a relative term, what's blue to you may not be exactly blue to me. Remember, it's always better to use quantitative observations than qualitative, but sometimes that's all you have. Odor, and I just want to point out that this is not a change in odor, it's just that something has an odor to begin with. Hardness, probably the only thing that you might be familiar with that right now is when you looked at rocks or minerals in 7th, 6th, 7th, or 8th grade and looked at Mohs hardness scale. State of matter we've talked about. That's what the whole last 2 chapters were about, if it's in a solid, a liquid, or a gas state. And density, which is mass divided by volume. Okay? Those are things that have to do with appearance. Those are all physical properties. If I take a piece of paper and a white piece of paper and use a red marker on it, I've changed the color, I've changed the appearance of it, but it's still paper. Or if I take a lump of clay and make a vase, and then I change it and make a bowl out of it, I've changed the shape, but it's still clay. We haven't changed what the makeup of the substance is. Okay? Then the second set of physical properties fall under the category of behavior. There are quite a few of them there listed, and some of them are kind of, you should already be familiar with them. There's probably only 2 there that we really have to learn that maybe you've never heard of before in your educational experience. So first of all, thermal conductivity. Thermal conductivity is the ability to conduct heat. Remember, therm means heat. So if it can conduct heat, that is a physical property of that particular substance. Like metals are very good conductors of heat. That is why our pots and pans are generally made out of either copper, stainless steel, aluminum, or iron, because they conduct heat very well. Conversely, if you look at what the handles are made out of, or what the stirring spoons are made out of, or whatever, generally they're rubber or wood or silicon or something like that. That is not a very good conductor of heat. And if they are made out of metal, then you use a hot pad or some such thing that's made out of a material that is not a material like cotton, that is not a good conductor of heat. Okay, so, you know, if it's, let's say that you're going to go on a hayride and it's in October and you're going to serve cocoa. You're probably going to serve it in a styrofoam cup. Styrofoam is not a good conductor of heat. And so if what's inside the glass or the cup is hot, it's going to stay hot. If it is cold, it's going to stay cold longer. Okay, so thermal conductivity, you can look at it as it conducts heat well or it doesn't conduct heat well. We usually call those insulators, but it all has to do with thermal conductivity. Electrical conductivity is another one. Electrical conductivity is the ability to conduct electricity. Again, metals are very good conductors of electricity. Malleability might be the first term that you're not real familiar with. Malleability is the ability to pound something into flat sheets. I always remember this. For me, it's easy because a mallet, I know, is like a hammer that you use to pound. Okay, so if you can pound into a thin sheet, that is malleability. Metals are very malleable. If you try to pound into a thin sheet of non-metal, it's probably going to break. It's going to be very brittle. In your videos that I would like you to watch, there is an example of the making of aluminum foil, and that is a good example of malleability. They don't exactly pound, but they press with pressure on rollers, which is the malleability part. The second term that you may not be real familiar with is ductility. Ductility is the ability to pull into a wire or to draw into a wire, like copper wire again, or barbed wire. Again, this is a metal physical characteristic or property. Non-metals are too brittle. They will not draw into a wire. The second video that has to do with aluminum cans that is on your YouTube list shows how they make aluminum soda or pop cans. And they do draw those out, so you can see it there. Solubility we talked about when we talked about homogeneous mixtures or solutions. That's the ability to dissolve in something else. If you have sugar water, for example, you still have sugar and water. Okay, that's a physical property. You can get your sugar back, you can get your water back. The substances did not change their identity. If something is magnetic, which is generally a metal property also, that is a behavior physical property. Boiling points, the point at which something boils. Melting point, the temperature at which something melts. Are physical properties. And the ability to flow, which is only liquids and gases. Those both have the ability to flow. Solids do not have that ability. Those are behavioral physical properties, and we can use those to separate mixtures. That's why it's important for us to know. You know, sadly, I guess, we're not going to be able to do any labs to separate mixtures, but we could use those properties to separate if we wanted to. Okay, so those are physical properties. Remember, up here, they are things that you can observe or measure without changing the makeup of the substance. Okay, it doesn't change what it is. All right, so if we look at then chemical properties, if I can get my computer here to scroll down. Chemical properties are a characteristic of a substance that indicates whether it can undergo a certain chemical change. Okay. I need another hand here. I'm not doing too good. And turn into a new substance. All right, so when you have a chemical property, if it actually happens, see, it indicates whether it can undergo a certain chemical change, not that it does, okay? But if it can undergo a certain chemical change and turn into something new, then that is a chemical property. So some examples are flammability, or if it's combustible, if it reacts with water, if it reacts with light or acid or oxygen. Those are all examples of chemical properties. In your, I think you know what flammable and combustible is. I don't think that's anything that's outside of your realm of experience. But reacting with water, if you remember when we talked about sodium and chlorine earlier in the year or in the semester, sodium is in group 1. It is in the column clear to the far left of the periodic table. Everything in that column reacts with water. In your YouTube videos, there are multiple short little videos that show how reactive those metals are when they're put in water. Okay, you'll enjoy those, I think. Some things are reactive with light, like hydrogen peroxide we've talked about before. It's usually found in a brown bottle. A lot of your medicines are found in brown bottles. It's not because brown is cheaper to manufacture. If that were true, then everything would be in a brown bottle. But it is because it keeps out the light. If you put hydrogen peroxide out and it is in the light, it will decompose and you will no longer have hydrogen peroxide. Okay, so the property is not that it actually does undergo that chemical change, but that it could if the situation allowed for it. Okay, just because, you know, the clothes that I'm wearing right now are flammable, but they're not on fire. But if we were around fire and I, you know, tried to light them on fire or whatever, they would burn. Okay, so it's that it could undergo a certain chemical change. Okay, I think what I'm going to do is stop this video. So these are all the property parts of your notes. And then I am going to go over the changes next, in the next video. Okay?